Hello everyone, today I'm going to solve and analyze an interesting problem related to the electric field in a uniformly charged infinite plate with a spherical cavity. So firstly we need to understand the problem, the setup. We are given an infinite plate with a cavity inside that cut out from plate. We have a thickness of the plate and charge density. We have here charge, and a spherical cavity is cut out from this plate, so that means there is a region without charge in the middle of the plate. So our goal is to find an electric field at point A and B. So you can see here point B and A. So also we need to find the dependence of the electric field voltage along the straight line OA on the distance to the point A. We need to create function. So to solve this problem we need to use superposition principle. Since the cavity itself is uncharged, we can use the superposition principle to analyze the problem. This means that instead of considering the cavity as an empty space, we imagine that the original plate is still there and then add a negative charge distribution inside the cavity. We can take a original plate with charge density plus charge density, and we can take a plate with cavity that will be minus charge density. So a uniformly charged plate with charge density plus charge density, and sphere with minus charge density. So this idea behind this approach is that the negative charge distribution cancels out the charge inside the cavity, creating the same effect as if there were no charge in that region. So now we need to calculate an electric field at point A. So we've already know Gauss law, flux equal to electric field multiplied by small area inside the closed system. That will be equal to charge inside and epsilon 0. But in our case we need only this part. We need to know only this formula. So to find electric field at point A we need to use this formula. Electric field area epsilon 0. So instead of area we can take 4 pi rho square radius square, but by looking at sphere we can know that radius equal to h over 2 square, so we can replace it to that. But we don't have charge in our case, so we need to write it by using charge density. So we already know charge density, formula of charge density, that equal to charge over volume. So we need to write it by volume. By the way, we'll also know a formula of the volume of sphere that equal to this one, 4 over 3 pi. We can replace it h 2 cube. So we can write area by volume, like area equal to 6 volume h by like dividing it and find it. So our formula will be like 6 volume h equal to q in and epsilon 0. So here we can find epsilon by electric field at point A. It will be equal to q in h 6b epsilon 0. So this formula will give us charge density. So our formula will be like rho h 6 epsilon 0. So it's the answer for our electric field at point A. So at the second step we need actually to find electric field at point B. We actually do the same thing when we analyze a field at point B, which is located on the surface of the cavity. Like, actually, we should know electric field of the plate, like with Gauss law also, area equal to q in epsilon 0. Instead of area, we can replace it like volume over h and q in epsilon 0. So this will be equal to q in h volume epsilon 0, and this one will give us charge density. But for electric field at point B, we need to consider the field on one side of the plate, because a uniformly charged plate like creates an electric field that is symmetric on both sides. But in this problem, the cavity and the sphere introduce an asymmetry, so we analyze the contribution from only one side. So we need to divide electric field of plate to 2, and we will get rho h to epsilon 0. So now we also need to know about cavity's electric field, that will be equal to electric field of at point A, because the field inside a spherical cavity is uniform, and at point A it's inside of the cavity, so we can write it like this. So it will be equal to this one. So now we need to find electric field at point B, that will be equal to B prime minus cavity. So let's find it. Rho h 2 epsilon 0 minus rho h 6 epsilon 0, and then it will be equal to 6 2 by epsilon 0 and rho h 3 epsilon 0. And it will be our final answer for the second one, for electric field at point B. So now we need to create a function for along OA through OA that will be equal to, here we can, that like we use the same formula, Gauss law, finding the field along line OA, like finally we determine how the electric field varies along the line OA. So Q in epsilon 0, instead of A we write 4 pi rho square, but we need to calculate charge by charge density, so we need to use volume also, 4 pi rho square, and we can write area by like 3V air, 3 volume radius. So here we can write 3V radius Q in epsilon 0. So our function will be equal to Q in multiplied by radius 3V epsilon 0. So this formula will give us charge density radius 3 epsilon 0. Yeah, and that's our final answer. I've also created a function of that graphic. Like here we can see the function. So by changing the by changing charge density, we can see how changes our function graphic. So finally we understand that we solved this problem by using the superposition principle, replacing the cavity with an imaginary sphere of charge minus charge density, and then applying Gauss law to find the electric field at different points. We solve this solution. So that's it. Thanks for your attention.